Good evening, Doctor. What I'm going to talk about today is design and analysis of experiment with a single factor. My talk is divided into 4 parts. First, I would like to introduce the background, and the second part is experiment. This part includes objectives, subjects, variables, design, and the data collected. Next is the result. It covers analytics and findings. The last part is the reference. So for the introduction, actually in many integrated circle manufacturing steps, wafers are completely coated with a layer of materials such as silicon dioxide or metal. The unwanted material is then selectively removed by etching through a mask, thereby creating circuit patterns, electrical interconnections in the area in which diffusions or metal depositions are to be made. A plasma etching process is widely used for this operation, particularly in small geometry applications, and the chemical species in the plasma are determined by the particular gases used. Fluorocarbons such as C2F6 are often used in plasma etching. So the engineer is interested in investigating the relationship between the RF power setting and the etch rate for this tube. So the next part is the objective experiment. So the objective of an experience like this is to model the relationship between etch rate and the RF power, and to specify the power setting that will give a desired target etch rate. And the engineer is interested in a particular gas in the gap and wants to test for levels of RF power 160, 180, 200, and 220. She decided to test 5 wafers at each level of RF power. So this is an example of the single factor experiment with 4 levels of the factor and the 5 replicates. Then the 20 rounds should be made in random order. A very efficient way to generate the round order is to enter the 20 rounds in a spreadsheet. Generate a column of random order numbers using the rand function, and then sort by that column. Suppose that the test sequence obtained from this process is given as this picture. So then, the next slide, the engineer runs the experiment that we have designed in the indicated random order. The observations that she obtained on etch rate are shown in the table. Actually, for the results, it's always a good idea to examine experimental data graphically. You can see Figure A presents box plots for each rate at each level of RF power, and Figure B presents a scatter diagram of etch rate versus RF power. Both graphs indicate that etch rate increases as the power setting increases. So for the result, there's no strong evidence to suggest that the variability in etch rate around the average depend on the power setting. So on the basis of this sample graphical analysis, we strongly suspect that RF power setting affects the etch rate, and the higher power setting results in increases the etch rate. Lex is my reference. Thank you.